Okay, hello everyone. This is the last section for us in this bootcamp. And oh, sorry. Wait a minute. I need to share screen in pause. Okay, this will be the last section for the bootcamp. So today our content will be a demo. And we mentioned that we will have a certificate today, but like we have a discussion with the teaching team and we decided, so we will issue the certificate after you have provided the evidence to us that you're actually using what we have teaching to deliver some projects or making good progress with your projects. I have checked with Peter's work, so Peter actually already done quite a good progress in his own project. So we will give him the certificate today. Do you want to take it now or? Okay. So and however, but if you guys, because next week will be the project week, so if you guys have any problem or issues encountered in the next week trying to implement your own projects, you can using the Discord send me a message or send me an email, or just use the Teams chat, send me a message. We can help you progress in your projects. Also, after this week, afterwards, if you have made good progress with your own projects, and then you show us the evidence, we will still issue the certificate afterwards. So it will be something like the online platform, like learning. So after you meet our criteria, we will give you a certificate. So hopefully can control our learning outcome. So go back to today's topic, which is a project demo. We have talking a lot of different small components in the past 3 weeks, from the DevOps or development environment setup, the Docker, and how you collaborated as a team, to how should we architecture a full stack platform, and how to use a Docker, get them setting up. And then we kind of dive a bit deeper in each kind of component and sections, front end and the back end with Django, Azure, and also database, and also the Python package development, what you should care about. And in the last 2 days, we're talking about the authentication evaluation. How can you bring your product into a production-ready status with proper permission control? And yesterday we haven't when it's doing the live demo, I haven't been able to set it up properly. But afterwards, I actually figure out the problem. Yesterday, we stopped at the places is because AWS, after you restart the instance, AWS will replace with a new IP. And our DNS IP record haven't been changed, which means the DNS was pointed to a server is not the server running our code. That's caused the problem yesterday. However, afterwards, I have uploaded the code, like the videos, demonstration videos online yesterday afterwards. We have been able to get the demo, full stack demo being set up properly. Afterwards, we can give you a quick show with the CRCD things. So when we go to here, this is where we stopped, and then I kind of record a new video, walk you through how to do that. And the code, all the latest code have been updated to these 2 repos. And you can see it from here. That's the CRCD for the front end. The versary will take control of that. So it means it's being deployed successfully. And for the platform, we actually have set up the CI/CD by ourselves, so you can check it from here, like the whole deploying process. And the CI/CD code is here. So if you want to copy what we have done, then you can check what we have done here. This is the CI/CD, how to trigger it. And the Nginx configuration, I have actually updated the Nginx configuration here. So if you want to deploy your application to a server. You can copy the code and make it use in your own scenario. And after that, we can see all of the stack actually is working. The first one is the front end. So we can see this is the front end login page. And we can try to log in with account we actually created. And it's all on the cloud now. I think I used the wrong account. So you can see it's basically working with full stack deployment. And the backend Django interface is accessible by this page, and username password is admin and password. And you can see it from here, that's the same as what we have done locally. And also the Azure's interface, as well as vector database interface. And actually, vector database have some advanced usage is, I think this URL will give you see this interface. So you can kind of control what happens in the background with vector embedding. So until now, next thing is every time if you want to push some code to the cloud, for example, in the front end, if you want to push the code to the cloud, you should you shouldn't push directly to the main branch. You should, as we discussed before, you should branch off from the main branch and push it to the GitHub repo, and then use pull request to merge your native changes to this main branch. And then the adversary will take control of that and doing the automatically deployment. So your native code will automatically be deployed to the front end. Same thing will happen for the platform. We will demonstrate this kind of CI/CD, how it works. So it's the same, like you should branch off from the main branch. And then when you push to the cloud, you use a PR and get the code being deployed to the main branch. And if there is new changes going to the main branch, then your CI/CD will be triggered and it will be running the code inside the GitHub workflow. That's kind of the script we are using to update your application. It will log into the server and restart the containers. And so in the background, your code will running and the platform will be updated. So that's something left from yesterday. And you will be able to check the 2 videos and have an idea about how can you do it manually by your own. So if you have a problem, you can follow that. And if you still encounter issues, cannot bring it up and running, you can send me a message. I can help you resolve that, get your application up and running on the production. So next time when you have an interview with someone or have a demo section, you can just send them a link, which is the ideal stage for the whole bootcamp, what we want to achieve. And it goes back to today's project demo. We want to put all the bricks together to build some code, which is a full stack AI thing. So it's like from the slide side, it will be fairly simple and straightforward. If you get an application you want to build, then normally as a software engineer or a developer or solution architecture, you basically have 3 steps you need to follow in a high level. First, you need to go there to analyze all of the request to understand what's a business request, and then convert the business request into the technical requirements. So under this stage, you basically can have an idea about all of the functionalities and user storage features you want to achieve. This actually was being teaching in UWS unit software requirements and design. That's a unit when you're taking that one. If you don't have this kind of experience to build a full stack application, it won't make sense to you. You will feel like it's something not meaningful. But after you're doing this kind of building a product by yourself and you go back to learn that unit again, you will find out that unit is very helpful and useful. So hopefully if some of you guys have like do some project by yourself next semester, you can learn more things from that unit. So basically after the requirement analyze was done, then that's kind of the role, like the job title called solution architecture where comes out. He will do the system design. But under this kind of project, the solution architecture is yourself. So we already give you the architecture about the full stack. How should we set it up? Then the next thing about the solution architecture is how can you set up the communications between different components to get the data flowing from somewhere to the front end and interact with the front end. So that's a system design part. And after you done the system design, then that's actually the last step. Normally in the industry, when you're trying to deliver a project or deliver some code, 70% of your time is actually spent in the meetings, discussions, and requirement analysis. Only 30% of your time will be spent on the real coding. So coding actually, even we have teaching you guys so many about the coding side of things. Actually, when you have a job in the industry and you're really trying to deliver something, you will find out in your daily operation, most of your time actually is spent in the meetings and the discussions to try to make sure the effort you put it into the code is not wasted. So you don't really want to write some code and someone comes back say, okay, you totally get it wrong. So that's basically what most of the time was spent. So our demo project idea is this. So we're trying to do a chat with maps metadata application. So we wanted to do an interactive geospatial data exploration. And the core features we're trying to demo is we wanted to have a natural language interface. And the natural language will be converted to the embedding. And in the background, it will do the similarity search with metadata of the spatial data. And then it will find out which spatial data is most relevant to your question. And then on the map, it can navigate to that specific places. So the functionality for the front end communication is you need to have an endpoint, which the input is a natural language question. And then it will use the embedding model to embedding that to a vector. And then you need to do a vector search in the vector database to figure out which record of all of the chat data were like most similar to your query. And then for the front end, it should be returned with the most similar one. And then you should use JavaScript or libraries to do the interaction, navigate you to that specific polygon. And so in this way, the backend functionality is you need to get that data being downloaded and doing the stage one processing, as we mentioned in the introduction to the RAG. So you need to get the data downloaded and process the data, embedding all of the metadata in some format and insert it to the vector database, which will be the task for the Python AR module. So you can see we already we have a two-stage in this AI application. So the next part is we need to process the data, which is stage one. Then these many things after the analyze we just discussed, it should happen in the Python AR module package in the code there. And then for the interactive part, which is the user part, in the right part is the user will doing the discussion and send the message to the API end and return things back in the front end to do the interface and the UI UX things. So that two things are being sorted out. You know exactly what's the front end and the Python package we're doing. However, we can see like after this discussion, we find out the platform actually is in charge of a lot of roles. First, it needed to have several endpoints. At least it need to have one endpoint. The front end will send the request and it should return back with the maps navigation information. So we know then API side, the platform side, needed to have an endpoint to do that. And going deep from there, we need to get the data stored in the platform end, which means then we need to define our data structure. So after this discussion, and this kind of keep asking yourself questions process, you basically trying to figure out what you need to do in different components. So next thing is you can kind of figure out, have a list of the functionality and the tasks you need to done for each component. And that should be the things you put in the project GitHub issues, as we discussed in the first week, the GitHub action and agile process. You need to have the component and create the issues there and starting track your progress to make sure you work well in each different tasks. So I think even I talking about so long, I don't think it will get you understand it very easily because you need to make it into practice so you can understand this kind of progress, why you need to do it this way. Then I think I will starting with like demonstrating what we want to achieve first. So basically the data source, the geospatial data, which we're doing is this data called WebMax. WebMax is a GSWS data, it's open source data you can access online. So for example, here, you can see, you can search it and get the data. That's the WebMax interface from the GSWA, but that's a bit more complex. What I mentioned before is we have a lot of data from the WA government. This is actually one of the things in the WA government released the data. So you can see this is the data, WA government data, like a repo. So within here, you actually have a lot of data you can do in the process and trying to build application. Just in case you don't really have any idea about what's the application you wanted to build. But we select this data called mineral exploration reports, and then it will have a section for you to download the data. And when you click the download, it will take you to this download page. Because we are handling the geospatial data, I'm not sure whether you guys are familiar with the geospatial data, but we can download it and give you a demo. So we will download this shapefile. You can also download this other several different formats. They're actually exactly the same. It's just different ways to store the data. And after you download it, the university internet is very slow. After you download it, you should be able to, oh, I actually already downloaded it beforehand. You should be able to unzip it. After you unzip it is a shape file. It will have the data dictionary and the metadata about what the data was doing. So that's a good part of the Australian governments. Australian governments, when they provide the data, they normally will have this kind of documentation there for you to understand what they want to achieve in the data. So you can use the data properly and have the domain knowledge there for you to do understanding. But to open the shape file, you can use the QGIS to open it. If you don't know what a QGIS is a software tool which is very popular and widely used across the whole world. It's an open source tool to view this geospatial data. If you are interested, you can dive a bit deeper there. But you can see when I double click it, I actually been showing a map of Western Australia with so many different polygons. That's the geospatial part of this data, which is a polygon format. And when we mention in very beginning says metadata, how can we view the metadata? It's actually here. When you right click and right click this layer, there is a button say open the attribute table. So after you open the attribute table, which is here, you can see there are so many different column names here. That's actually exactly the same as a relational database and the tables. So you have a column name and you have a value. The only different thing is this record will have a geospatial record, which is a polygon, the polygon data. So the polygon data is something we are seeing here. And the goal we want to achieve is each of these records have a polygon information, but when you're trying to do some search, like if someone trying to navigate through it, the whole data set here in this document is around 100,000. So it will be extremely hard for any like a minor exploration reports consumers to easily navigate all of these different records. And with this large language model and generative AI concepts comes out, we potentially can get this different field being embedded. And then when we're trying to do a fuzzy search or similarity search, it will it will navigate us back to the specific geometry area and the document, so it can get people like navigate to what they want to search easily. So that's basically the goal of our project demo. And the requirement analyze after the analyze before was we just discussed, we find we actually have these many steps we need to follow. First, we need to load the shapefile we just downloaded and save it into the database. And load the shapefile process should happen in the AI module side, but the save to the database procedure should happen in the platform side, which means we need an API there to get this communication work. And then we need to embed and store the vector of the metadata into the vector database. That's the second requirement. And we need a map visualization of the geometry field together with metadata. And we also need an API endpoints for the front end to do the query with the chat and search the vector to be to locate the relevant records. And the front end UI UX should be able to navigate through the map. So the system design is still this one. So that's basically the whole bootcamp, what we're trying to deliver and trying to implement. But in our application, we don't have this knowledge graph side because that's not a current the demonstration is not that complex enough, requiring a knowledge level, like knowledge graph level integration. But here we can see like this data pipeline, we're in charge of node the shapefile and processing it, and then call this platform API side to insert it to the RDBS. That's the first functionality we need to implement. And then we needed the platform side, the pipeline, the module, AI module side, being able to use the embedding model, embedded the metadata, and also save to the vector database. That's the second functionality we need to implement. And then for the front end, we should give them the possibility to be able to like call a REST endpoint. And then the REST endpoint will search through the vector database and return the geometry information back to the front end. So that's the third key functionalities we need to implement. That's all we want to do. I think when I was talking, you probably want to be able to understand the whole things we want to achieve. So actually, this morning, I spent probably 1.5 hours, and I already get that implemented into a demonstration status. I will show you what we want to achieve, and then I will try to spend some time, like get you work together with me to get that implemented. So basically, I have already using the endpoints. So my UI, my schema is here, my endpoints is here. So you can see I have metadata spatial. I actually already using these endpoints, insert all of the data in the GeoJSON to here. And because of that, we've been able to see it from this table here. That's the data from the QGIS I just showed. So you can see it has the geospatial information and all of the actual metadata. That's basically the first goal we want to achieve, right? And then the second goal is we wanted to get them to be embedded and save to the embedded database. That's another thing we actually already achieved, which is being saved here. So we can try to, I'm not sure how to visualize it. Yeah, so you can see here, we actually already get them processed to the embedded and saved to the embedded database. And it have some way to do the graph view. That looks pretty good. But that's the second goal we want to achieve. And that should be the milestone or how you mark as this second task to be done. And the third one is we wanted to, in the front end, we are being able to do the navigation and the chat with a map to navigate to your metadata. So I also get that done in the front end already. So for example, in our database, I want to search some like a Perth or Western Australia related project. That's the query I was mentioning. So it's a natural language query. and you click send, it will be sent to the API end. So there will be the API code there. And in the background, it should run something. So you can see in the background is actually to do the like a vector search we mentioned. And then the matching score for this file is with the metadata is 0.84. And you can see I'm using the top 10 or top 5 to be returned. So I mentioned all these top 5 files there. But the navigation of the map for the demonstration purpose, I just navigated to the first, the top files spatial data, which is what we have seen from the QGIS. And we want to be able to see their properties and the metadata. This is how it works. So you can see like after you click it, you will be able to see the meta information inside it. So you can see this is basically what we want to achieve. And because I already done it and give you the demo, so you have a better idea about what we want to achieve. So then we have a pretty clear goal. We need to go back to do the implementation. Then in the, I'm not sure whether I can get all of them being demonstrated within this time frame. But before was in the past several weeks and several days doing the demonstration, what I'm focusing on is actually the platform and the front end side, the demonstration. So you already see how the code was working there, but I haven't actually showing how to do the AI module size code. So what I were trying to achieve is I were trying to at least get the AI modules part done with like processing the data and save it to the database. And the second goal, if we have time, we're also trying to get it done, which is embedded the metadata and save it to the vector database. The front end map navigation, if I cannot get the demo data in this section, I will try to upload another separate video and you guys can check the video regarding how to get that done. So let's start the first two goals. So the first goal, we wanted to be able to process that shapefile and store it to the database. Then how? Where we start with? I think as like from my personal experience, we will prefer to start with get the database sort out first. So because we already know the data structure, so we were trying to get the database side being sorted out, which means I need to first working on the platform code base is this one. And let's check, do I have other things running in the background? If yes, I will stop them and just running this one. And so this is the code base we demonstrated before. So slowly. Okay, it's been stopped. And we were trying to remove all the existing containers. And then we will start the full stack of the platform side. And similar to, see whether we have a container name. We don't have a container name. So we need to find out what's Django's ID, which is this one. We go inside it, and then as we have done it before, we want to get a things logic to be separate. So we need to first create a separate app. As we processing the WebEx data, I probably just create a new app called WebEx. So this will create that. And I think same thing as we done before. After you created the app, you just need to register it here. And after the app was registered, then it's a time we need to get the spatial data being saved in the database. So to get it saved with that QGIS page, you can see there are so many fields there. However, like that's a side where you probably need some justification or depends on your scenario, decided how you doing this data structure, like a definition. But for me, what I prefer is I wanted to know what's file name, and I know this a number is it's a unique ID. So what I want to do is, and I also wanted it to be more dynamic and flexible later. That's where we wanted to, why we want to use a JSON field. So we want to build this application to be later if we have a new shapefile coming, and we still can do the same chat directly without too much changes with our code. So which means when we trying to define our the database structure, I will wanted to get it to be flexible enough. Then in this way, it means I probably only wanted to have 3 fields, and all this diversity of this like a meta field, I will trying to get them inside of the JSON. So this means in the end of the day, I will have it like this. So we call it spatial meta data. Let's call this model this, and let's check how to define the modules in other applications. So we can define one probably. So modules. And to move this. So what I want is I need to have a file name, which is a character, and we give it a help text. And also we will want to have metadata, JSON, which is a JSON field. And I want it blank to be true so I can be tolerant. And also I will want the default to be a dictionary. So in this way, I define 2 fields here. This basically should be enough for our purpose in theory. I'm not sure JSON field should work. And then we wanted to be able to track when we update it and who updated it. So we do it this way. In the last, we were wanted to have a geometry field there. So this is how we do it. I'm not sure whether this is correct or not. I think the geometry field will have a spatial one. So I will go there to check my previous code. It's just the need to check the documentations, models. Is this model a spatial model? Yeah, it's a spatial model. So because geometry is a spatial, like a database structure model, so you probably need to import it from another library, not the Django's like a predefined library. So we need to update this to this one. And then after this, we should be able to have the capability to define it. And the arrow says I defined it wrong because it's not modules. So until now, we should be able to define a proper database structure. Let's see, is that true? Where is my previous module? Yeah, okay, I also needed to put this here. This is, so this serial ID is the ID to mapping whether your map, like what's the coordinates system it is using. The 4326 means it's a GPS coordinates it's using. So it's just a standard way is how you're using that. After I doing the definition, I need to do the migration definition. So I need to say I added the metadata and doing the migration. That's all standard. And then I should be able to put it in the admin page. So I need to, from the WebEx module, import the spatial metadata, and I will want to register it. And after this, I should be able to, in the backend, not sure your state whether my username and password is still there. Yes, we are there. So okay, we created one, and it says this geometry things doesn't exist, which means we potentially needed to install something else. So that's the places we hit the problem, and then we ask the ChatGPT. What's the GIS? Okay, so it means you need to put it into this one, into the installed app. So we just need to follow their instruction to see whether that solve the problem. And let's see whether just install it to solve the problem. Yes, it's already solved the problem. So that's the problem, why it happened. This means like our database structure definition is already done. Then the next stage we need to do, as we discussed, is we need to have endpoint. Get the API, get the AI module and being able to upload data to there, which is also standardized with as other modules is creating a serializer and the view. So because we already have other code in the previous, we can just do the same patterns as what we have done before. This is basically why AI can write the code for you very easily. You can see when you have done the pipeline once, later when you're trying to redo it and get the business logic delivered, it will, the second time, you're basically trying to copy yourself and then do some adjustment. That's all you need to do. So which will be make it much easier. So we need to create a serializer. And then within the serializer, we need to import the serializer and from the WebMax, the module, import this spatial metadata. And then we need to create a serializer, which will be named as the spatial metadata. That's basically you inherit it, you get it. And then from the view, it's the same as what we have done with farm view. All you need to do is you from the Django, the rest view set install these things. So you install it in, and you need to from the WebMax serializer import this serializer in, and then you can see the. Let's try. It's already knows what you want to achieve. So we also need to install the model in. So the model is being imported, and serializer define it, and all other things we actually don't really need them. That's basically done after you define the view set, like what we have done here. And then is a URL. So you have a URLs. And then we copy it from previous primaries, how we done that. That's how we do it in the primaries. We copy that and then we do the update. So we not the primary views, we are the WebMax views. And we need to install the spatial metadata view set. And then we give it a URL, spatial, SPATIL, metadata. And we put this view set here. And we don't really need this kind of API things anymore. And I think that's all, right? And the app name is no longer the. I don't think we also don't really need that. So after this, we can just ask the ChatGPT generate for me. So get this URL, the PY fixed for me. So you can see if you know what you're trying to do, you probably have half the code was being implemented, then it can do it for you. So I just copy the code here, but I probably don't want this API things in the front. I just want to do something like this. And until now, it's not yet ready. We need to also include this one into this one here. So it will be have a pass, not a dashboard. We wanted to include the spatial. And or we just use the WebMax. The name itself will all depends on you, but the principle is you need to give it a proper name at least. So that was being done. And then we needed to go to the backend because we have set up the Swagger before. So let's see, something wrong. Let's try to restart it. It's potentially because some of the code when we updating it, it's have the problem and the application was exit. But we can try to restart it to see what's okay. Django is back, and the Swagger here, and then you can see here when you have the post, this endpoint is already there. This means from the API side, we get everything works already. That's all we need. And as a good practice, you should basically check out to a new branch, which my branch will be the new feature, WebMax. You should use a pattern as we discussed before in the previous, like how to do the agile like a pattern. And after this, our API end to get the data stored is working. What we need to do next is in the modules, we kind of need to process data and upload the data to the cloud side. Then this is how you do that. This is a code base we haven't touched on for the AI module side. And I will also check out a feature for the WebMax. And to get started, we know we have several modules we want to use. The first thing is we needed to have a data loader, which is processing the data. We put it as a module. Actually, it's wrong because we mentioned if you wanted to do a module development, you should do some data structure, like a code structure like this. So inside it, that's actually the source of the data. And then to get your code being separate, logical separately, you should be able to create a separate module just for the data loader. You can name it as what you like anyway. We have also mentioned we want to have one is do the embedding. So we have another module called embed. And we also needed to communicate with the API side. Then we basically have a module called utilizer. And inside it, with the S is better, more like a better naming. It's trying to get it with the S. Utilizers. And then inside it, because we need to do the API call, then we create an API calls. So we were first get the API working. So API, if we want to get it working, it will means we will have we actually have two API end to communicate with. One is a vector, like a conjoint API we need to communicate with. Another is the one we developed. So we will give them separate name. One is called a platform API. That's a class we were doing, and we will have initialize. That's code is not really meaningful. But the API itself, what will be more meaningful is like which endpoint you want to point it to. So this means if we want to test it properly, we need to set up some environment variables or some constants to manage the variables. For example, the platform API URL. But now we are doing it locally, which will be the localhost 800. And also we have also mentioned we needed to use a token to do the communication with the cloud side. So we just give it a token thing. But you can see until now, we shouldn't get the code being plain text stored here, which means we need to use other ways to manage these security credentials. There is a lot of way to do that, but I would prefer the way to doing it using this one. So we will create a configure YAML, because nowadays you have so many different configures you want to manage, then it's probably will be better to say, I put it in a platform, and then we have a URL is now it's HTTP. And then for the token, it will be something we put it there. And if you wanted to get it to the production, then this will be changed to the production one. You just need to change your configuration file. And which will means I want to ignore this configuration file. So as we mentioned before, when you at this stage, you will want to generate a git ignore file for me for a standard Python package. That's what we want to achieve. So it will generate one for you. As I said before, you should do it this way to get a most common git ignore thing in. So or most of yours should be ignored file, then will be ignored. But on our scenario, I also want this configure YAML file being ignored, which I will add it manually later. And then in the admin, in this configuration file, we said we want to get a token. Then the token is things we actually mentioned and already set up in the section in the authentication for the last part. So basically what we will do is we go to this token, and then we create a token for this specific admin user. There is already a token there. So you can see this is a token. You can communicate with the front end. So I'll put the token there. And then in the constant, I wanted to actually to read these kind of two variables from this configuration file. Then what I wanted the Cloudy to do it for me is I wanted to set, I want to read my constants setting from configure.yaml in a Python package. Give me Python code. Like nowadays, it's basically, we keep saying that a lot of times, like especially when you're trying to do the coding, is you just need to know what you want to achieve, and it will generate the code for you. See, this is what it's generating. So basically, it says that will be a configuration reader. So it's giving you all the like required things you need to do. So first, we need to create a class, and it's already done that for us. Then we just borrow it from here. So because it's also a utilizer, and we call it a configure reader, and we copy the code directly there. But you can see it's generating the code with just doing the, I think it's doing the print. Yeah, that's not a good best practice. So we will use from logger guru import logger. But I don't think we have the logger being installed. Then we actually also haven't created the environment. Then we use a conda, create a virtual environment. That's a command is have to do the condas environment creation. Let's try to do it here. Probably prefer this version, and I will call it demo. And in this way, it should be able to create a virtual environment for me. And I also should be able to have a requirements.txt to track all of my requirements. For example, the log group. And I need to activate my virtual environment. This is done. And then I need to install my logger group. And I put it here. So, and we mentioned it before why we using the PyCharm, but I haven't do a demonstration for you guys, like why we use PyCharm to do the IDE very efficiently. So this is why. So you can see I go back to do it again. So you click this one here, this is the places you set up the interrupters for your code, Python code. So I actually set up so many, and you can add a interrupter. So for us is Conda. You actually can get the poultry environment, which is we mentioned before. Pipe env is another thing we mentioned before, or system one or virtual one. You can do all of them. In fact, you can also to create a virtual environment from the Docker. They have options there. But for us, to get this one is Conda, and we want to use the existing environment. So we just do this setting, and it's done. While it's done, you can see what's the differences. Just now is just flashing out, but the differences is because I have installed this package under this virtual environment, and I have stated this Python interrupter to current this virtual environment I'm using. So it's give you the capability. Actually, it says here this package already there, but this one haven't. So we also need to install the, I think it's a py YAML. That's py YAML. Yes, okay, py YAML. And we also need to put this py YAML here. And after this, you can see the hint say you don't have this package is also dispirited. But this one says the logger, we haven't used that. Let's try to use that. We do the logger info and logger info. Logger info. And another tips is when you're trying to logger the exception, you can do in this way to do the logger exception in the Python. I would prefer everyone to do this way, logger exception. In this way, that's the thing I mentioned. When you're trying to do the code and it's running on the cloud, this log.error just will give you the error message, but this one will give you the message about which line of the code have the error, which makes you doing the debug much easier than before was. So why we like to set up this interrupter? The answer is here. Because I have set it up, you can just directly click it and doing this run. And it will run under current virtual environment. So for this one actually have an error. Error means it cannot find this configure YAML is because this folder, this one is not in this specific folder. I need to create a constant for the project root. Then I think in this way we should be able to do. And then when you're trying, this is another good package for you to manage all the file paths. It's Python built-in-one. I think you should use that if you want. No, not that you want. I think you should use this one if you need to handle this like a file operations. Then I will import the loggers because I will wanted to make sure my project root actually being processed correctly. So I need to from the AI4W dot rise constant import the project root. And let's try to do it. Just the error is because my project root is. So why we're using this path library is because you can just use this way. So it will give you the operational path. Doesn't like if you learn the Python from very beginning, they will give you like this OS path and do a lot of allowing operations, like the join. That's allowing. If you want to join, it will declare data like this. It's much easier. So let's try to see what happened. Okay, it says that haven't find this file, but we can see the router directory was being set in wrong. So we were trying to do it this way. So it should be the parent and the parent. Let's try it again, whether it's trying to figure out. Okay, this times it's working. So this configure loader this time it works, but what we will want. they wanted some configuration like this. However, our format is not something like this. We wanted to get the value is platform. It's something we have, and the URL. So let's see. So you can see it's working. And also we wanted to get the platform and get a token. And when trying to refresh it, you can see the path, this like a configuration are both being processed. And why we using the logger, actually I can show you something to say why I using this logger rather than the built-in logging things. You can see I log in something as critical. You can see very clearly, you know which line of the code is critical. And if it's warning, it will give a warning label, and it will also tell you which line of the code actually has a problem. For example, here is 97, is where you actually been logging from. In this way, your code will be more observable, and you can know what's happened, and doing the troubleshooting easier later. All of the things we are doing here during the development process using this all of the tools is trying to get us when we're trying to do the debugging, the life is much easier. So until now, we have this configure reading good. Then what we want to do, we probably want to do it here is configure YAML. We will give it a constant here, so we can use it later. And we should check if it's not exist. For example, we'll raise a error. This will stop your package from starting. And because we are using this like a library called a pass library pass, we can easily do this check. So you don't really need to write some hacky code. It's all tested. So after this step, we go back to the API. You should keep working on our API now. So we need to, from our constants, which is AI for that, then instance, import our configure YAML. And also we want to from AI utilize the configure reader from get the configure read and serve config is this, and then we wanted to get the API URL, which is from the platform. And what's the key we are using? It should be the URL. So in this way, you have a URL. And then we wanted to have the API token, which is this one. And we also should have the logger. Let's trying to make sure our token is also set up properly. And how you do the debug or developing when you're trying to do the debug, you haven't run the test, you use this way. You can see it's being set up properly already. So the next package we need to use is request, but we can find out we don't have the requests. We click that, it's being installed, and we put that in the function. So then next thing is in the API, what we want to achieve is add the spatial metadata. So we give it a name called add a spatial data, and that's the data. And we want to do the operation is that's a header we need to put in. You can see it's basically doing this automatically for you. Only thing with the problem is this spatial data's endpoints is wrong. You just need to go to your endpoints. Where is that? Is here called core. Oh no, that's my cloud one. So if you want to create a data, it's called a WebMax spatial something. Let me see how can I copy that. That's a bad part of this is you don't being able to easily copy it, but we can copy it. So we come here, we copy that, we have it. So in this way, we have then we want to check whether it's correct node. So if it's 201, that's standard way, means created. Then if it's wrong, then we need to give it another error. So under current scenario, in theory, we should be able to get the API request to create a data done with the API class. So next thing is we need to do a data loader, then call it a WebMax, and then we give it a class called WebMax loader. And I think some people probably using it somewhere to inherit from a data loader because that's a common name. But we haven't. We need to write it by ourselves. So for us is we need to have the shape file folder pass. And for Python, you should also give it the pass name. That's a pass. And then you should state the shapefile pass. But how can I read the shapefile? Like there is a specific package called GeoPanda. Is something similar to Panda, but it's have the geospatial support. So we just doing it that way. So we import it. The GeoPanda also have the GeoPandas. Like one thing you need to know is trying to know how to read the documentations if the AI cannot solve the problem for you. So this is the GeoPandas package, like documentation. You can see how you use that, like GeoPandas read. But I already know how to do that, so I just directly using that. The next thing is I want to know the data from this file, then which means I need to read it from the shape file. And because I also want to check whether my loading is correct or not, so I probably should want to know what's the shape of the shape file and what's the headers of it. You can see it's already done it for you also. And if it's man and you doing this, and then is where is a file, right? Like you need to know a shape file. Normally we will do as we said before in the previous sections of the Python package, we probably create a data folder and then get it ignored because you don't really want to get all of the data to be put on the cloud, but the data directory will be under this one. And to get the constant be used frequently, then you can declare a data directory like this. And if not exist, this time we don't really call any errors because it's fine if it's not exist. Then we do create this folder, or we just use existing OK making the directory. So if you don't have that directory, you can automatically create that one. And then we need to make sure we have the files, the downloaded shape file to be within that one. So we will try to copy it. This one, we'll copy it to there, and we get it to a normal name. The space, the spatial direct characters, all these spatial ways to naming your folder or files will be the enemy for you later to do the debugging. So always get your naming of the folder or anything to be simple enough. So I just know there are some /1/2 things in the background. So I just deleted that to make sure it's actually working properly. So go back to here. I needed to do is I need to from the AI for w.utilize.constants import the data directory. And then my path actually should be data directory. And this is my folder name. I do the copy and let's try to what's been, okay, it's been copied like this. So that's a folder name. And if I want to read, it should be read the shapefile name. Then I copy the shapefile name. And if you can copy it, you should copy it, because a lot of the questions, problems, or bugs are actually from there. It's like the naming. You probably only have I and L. You want to be able to support it by your I, but that's the key problems haunting you later when you do the debugging. So after I do this, I should be able to view the data or load the data in the GeoPandas, but it seems stuck to somewhere. So we potentially wanted to have another utilizer called oh, it's actually working. So you can see it's loading. There are that many records. Is 100,000 more records in this shapefile, and that's the top 5 records. I actually is logging the tops, not the columns. So I probably also want to log the columns. So this is how you do it. So this means until now we have been able to read the shapefile data into this data frame. And then the next step is I want to use the API to push the data to there in a proper format. Then I should go to the AI4.API, import our platform API. That's the platform. Okay, you can see this time when it's running, it's return all of the field it had. So in this way, you can have the understanding about how should you construct your like a data structure to feed it to the platform. So I have the platform API class. I initialize that. And if you want to insert the data to the cloud, you also want to track the progress of it. There is another package for the TQDM. This is extremely good to tracking the progress, so you can know where it is. So I want to also use that. Yes. And I actually haven't installed that. I need to install that. So type install TQDM. It's being installed. So I want to loop and then push it to the platform. So it will be something like this. And then I need to construct my data and send it to the cloud. But this data, what's the structure it should be? Where to check it? It's actually here. That's basically the reason why we have this endpoint thing. So let's put it here. So you can see in the data, I need 3 things. One is the file name, one is metadata JSON, and one is geometry. I think because this is all in the PyCharm, it actually already detected my code there. So it's automatically generate something like this for me. But this should looks like correct. I'm not totally sure. So next time I need to do is I need to run it and break it to see whether the first record can be like going into the cloud. So I click this. I put a break here to make sure if the code was running to this time points, like I can know whether it works or not, and it doesn't need to continuously doing these things. And why it's hanging out there is basically because the GeoPandas reader, the shapefile takes very long. Okay, this looks something wrong, and you can see from this arrow is the file name doesn't exist in the key of the shapefile, which means we just this is the easy problem. It just means we use the wrong field as file name. So let's see which one actually should be the file name. No, they don't have the file name. Then we probably use the type as this file name thing, so we can use it later. And let's try to restart again. At the same time, another good thing you should do is like, because we are running this platform code and the AI things is normally quite slow. And you want to profile your code to understand when you're doing the code, what's the bottleneck. So it will be good in your code. You have some timer kind of keep tracking about each individual part of the code, how long it takes. So, okay, it's have another error again. It's trying to solve this error first, and then we go back to there. Let's go to the cloudy, and where is the cloudy? Just open it. So it says my polygon is not serializable, which means this one haven't been doing serializer. But my code is quite simple and straightforward. So when I'm trying to, I kind of know why it's not working, but I don't really have a fix immediately from myself. So normally before I use a Google, no, I just use a ChatGPT the Cloudy trying to get it to solve it for me. So how it solving that for me? Okay, it's because the geometry was being included in this metadata JSON, and it's not actually a JSON format, which is giving a solution to drop that column. So the raw dictionary doesn't have that column. So hopefully this can solve my problem. Let's trying to copy the code here, and then here, restart. And go back to what we just talking about. We wanted to have a timer things to be able to profile the code of my timer. Then what I want to do probably is we need to create a class called a timer. So this is how to use a timer. Okay, this one is actually being added successfully. So let's trying to go to the cloud to see whether there is a data there. Okay, there is a data there. So you can see we use the API endpoints, and then the code is actually use that API being inserted to the cloud probably, and it's using that token to do the permission. If we are not 100% sure whether the token works or not, we can try to remove this line of code and redo it again to see what's the error. At the same time, we just define a timer. So we should want to use a timer in our loader to be able to profile how long each part of the code was using. So let's try to AI for the timer, import timer. And then we just notice that this process is actually taking a long time, but we're not sure how long it is. So we doing this ways, it should be able to give us a profile about how long it takes for that step. We can run it again to show you how it works, but you can see the authentication when we discussing on the, I think it's Tuesday, about how the API end was doing the module side doing the authentication. We use a token way. You can see when we haven't included a token in, it says rejected, which means the API end actually is communicated with the cloud authenticated properly. So, and just now we add the shape files kind of loading part to indicate how long it takes. I think it's actually haven't doing it very prop. I want to say it's loading and it's finished. You can see that's basically the timer code was added. The reason why using that, because we have this timer, we can use anywhere we have the code. And then you can see it's automatically logs the time, how long it takes to run these specific chunks of the code. And we just do an update is every time you enter it, you start this procedure and you finish the procedure, you add another two logs, which makes it even better to do the observability. And just now, when we're trying to do that, we have a break. So every time it's only created one file in the cloud, which is not good enough. And we also in the cloud, we actually haven't doing the unique key control, which is not good. But so actually we should in the formula key here, the definition of the data here, we should set the file name to be unique, but we haven't. But that's not a big problem for the demo. We just leave it there. But then we want to get all the data to be loaded to the cloud, which is this way. And we want to track how long it really takes to get all the data to be loaded to the cloud. So we remove the break and we add these logs here, and then we trying to run in this process. And starting loading the chef file. Waiting it a bit seconds, but at the same time, we have 3 goals. This basically means we finish our first goal, which is adding the data to the platform. And why we are doing this TPQD things here, where's my code here? Why we use this way is the all purpose is here. You can have the progress bar. So with the progress bar, when your code is running, okay, there is an arrow. Anyway, when your code is running, you can know what's the progress of it, and you can know in which step is actually finished. So again, it's all about the observability to your code. And because we have an arrow there to say there are some problem with our code, invalid floating arrows, that's should be the data problem. But that's not the key things we need to resolve today. Then we just use a pretty violent way to do that is we get our code resistant, which is writing the try catch to make sure we catch the error, don't get the code failed in specific places. So in this way, we definitely will be able to push the code to the cloud anyway. So until now, we basically get our first goal reached, and that's not a good way to view the code data being added on the cloud. So let's give it a define string. Serve file name. It will be more understandable in this way. The next step is we will want to get the metadata to be embedded. And then we need to save the vector to the embedding database, which is a conjoins vector database. So under this scenario, we will need to create a class called embed. And we need to select which embedding model we will use and how you do the embed. So there are several packages we actually need to install and use here. One is called Conjoins client. Let's go here, Qt client, Python package. I think that's one of the package we need to install. It will have the instruction, how should we install it? And we put it in the requirements. That's what we want to install. And this is, we just leave it to run here. It's actually will take much longer than we thought. Like it's 2 hours. Like it's doing some estimation about how long it takes. It says 2 hours. Until then, we can get all the data uploaded. Actually, we have better ways to do that. It's called a batch insert. We can aggregate, like for example, 1,000 records together and send one of the requests to the cloud to insert all of these 1,000 records in one chunk. That will definitely save the time. But that's something you can improve in your code. We want to do that in the demonstration now. But next stage, we need to do the conjoint. So we need to install this package. We need to install this conjoint client. That's the first thing we need to use. While it is installed the thing, this is a long one. We also need another way to do the embedding. We will use this library. It's also provided by the conjoint called a fast embed. They have 2 ways to install the package. One is with without CPU, without the GPU, and one is with GPU. So you can do this way, pipe install. So we just because my computer is actually a Mac, so I don't really have the capability to run it on the GPU. So I just install it this way. After this, I basically have these 2 things there properly. Then I needed to go to the embed class. So I need to install from conjoint client, and also need to use a fast embed to is that embedding or text embedding? I think it's text embedding. So they give the example, text embedding. So we need to first, and there are several different models you can use. It can be from the Hugging Face or somewhere. It will be default to this one. I think we will just use the default one. But if you want to give different embedding models, you can just use the Hugging Face, trying to find some embedding models. We have mentioned this, like what's other embedding models you can use. Oh, no, not this one. In the introduction to the RAP, you can reference back to our like a section there. We have a pretty detailed list about which one you should use and which one you shouldn't. But you just find the back like embedding name, model names, and then these text embedding things can actually take any parameters of the embedding name from the Hugging Face and download it, do the hard work in the background. That's why we use this package. So we will use this default one, which is the self embedding model. Text embedding. I don't really know the model, so I just deleted that one. And also I needed to initiate the Cogent client. But as you see, like similar as a platform API, for the Cogent API, we have two. One is when we're doing the test, it's locally. But when it's trying to run it on the production, it's on the cloud. So that's actually should be two different ways to do the authentication. Then in the configuration, we actually should have another section called Cogent. And you should have a URL here too. And I think they have we set that up in our platform? Let's see. They also have authentication ways to do the permission control. We haven't, so it means it's actually opened. But if you want to get that permit properly, we should set something like this. So you should have an API key. With API key, you should be able to like get your data being inserted with a permission with this API key. Otherwise, so make sure other people don't access your data. But under our scenario, the API key in this like setup is long, is empty. So we probably just say API key is just empty here. And then in this embedding configuration, we do it again from AI for that utilizer configure reader, import configure read. And we should be able to get the config. And then the conjoint, what's the parameters you can take? Like this is another good thing of this kind of ideas. You click the command line or the control line and you click it, it will take you to the definition to there. So basically for me is I need to get the URL, which equals to the URL, and then port should equals to the port. I haven't said the port. It should be all in the URL. Anyway, we will give it a port. And what's else we need? API key or something, but that's something else we need to do. Or you can just use a host, I think, I believe. But in this way, you basically set up your Conjoint client to communicate with a cloud server. And then we need to do the embed with text, right? So the text will come in, and then we need to do the embedding. The embedding is doing this way. The text specifically for this model to do the embedding in their documentation. Where is my fast it endpoint? It's here. So it's taking a list actually, and then embedding this list and return a list of it. So we only have one text, so we just embedded this text in this list way. And our vector should be returned in a list embedding, and that should be the first element in it. I'm not sure whether it's working or not, so I need to do the checking and the testing. So this is how I do to do the testing in my code. Import logger, and login.info, the embedding vector. So we can try to check whether this can give us embedding. And this potentially already go pretty, we already have a lot of files being inserted. So we just stop there. Like when you have time, you can get all of them being uploaded. If you want to test this out, we need to run the next embedding model. Okay. This is quite a lot of font, but when I'm using it in other places, I should use that. Oh, okay. I need to import this one. I used from configure YAML, and then I do the run it again to see it's. You can see the logs already. Like this is basically when it's trying to download the embedding models in the background. That's what's the logs from the fast embed, and then you can see in the end, so our return is this vector, which means we get the most important part, which is the embedding part works. So we probably just know it says my variable name is duplicated with this one here. So to get it safer, I should get them in a separate name, embedded text, and it should be a string to give it a type. So we get our code more safe. And then because we have that already, like we know the embedding part works. So the next thing we need to do is we first need to pull the data down and the text things down, and then do the embedding and then send it back. So the first step is I need to pull the data down, which will require the gate endpoint here. So you can see here, we actually have this. This is a post. Post used to post is used to post the data to the cloud, but get is retrieve the data or retrieve the data for the specific ID. I will retrieve most of the embedding data out, so I will use these endpoints. You can see how it works here. It's like you do this, you can see it's being returned. All of the embedding and all of the records was being returned, which means in my API instance of the platform, I need to add another class called get spatial data. And this is a list, which means I don't need to put any input there. I can just get the data. And until now, we find our header actually is shared. So we can use this way. We define a self header in the class. That's basically why we should use a class. So you can get your variables being shared. So you can see we do the code improvement now. And then response should equals to get. This is the get with these endpoints. And if it's 20, I use this one. And errors, I should log the error, say I failed to get the data from the cloud. And then in my code, I should be able to have, I can define a function called run. And this run function will stand alone in. I also need to, from the AI for API import the platform API. And then I need to initiate this platform of the AI. It's I name it AI. Oh, sorry, I name it AI, so it's giving me the platform AI. It should be API. The naming is confusing, so we shouldn't do that. We should fix that later. And then we using this platform API, we get the data list. So let's try to log how many data we actually like poured down. So to do this kind of test, we don't need this part. We just need to embedding, test the run part. We try it again to see whether our data is being poured down properly. Okay, we have 4. Hey, why is only 4? That's weird. Do we only have 4 records here? That's pretty strange. I have so many records. Oh, probably because of pagination defaulted to this many. But anyway, even it's 4 is already enough for me to, let's try to check the data. Spatial data list. First one. Oh, there is no 0. I think it's a dictionary actually being returned back. Oh, it's been pagination, so I should go to the result to check the real result, how many within it. It's the 4 is actually 4 keys there. So under this scenario, what I need to do is so until now, I've been able to pull the data from the API end. The next thing is I need to get my data being embedded. Then this comes to the interesting part is you probably need to do the justification. The metadata itself have so many content, and the title have its own content. How should I doing this kind of embedding? Like how can I construct the text to do the embedding? So later when we're trying to do the retrieve, it will be retrieved efficient. That's some justification you need to do and test the different ways to combine it and construct the embedding, because this embedding chunks will affect the later's RAG performance overall. But for us here now, for the demonstration purpose, I will do it pretty violently. I will do it just in, I will dump the whole JSON into a string, which is this way. I get the whole JSON into a string, and then I try to embed this JSON string. So that's basically my plan. And you can log what's the JSON string you're trying to dump. Okay, you can see it's works. That's kind of the string I'm trying to dump, and it's have embedding. So I will try to do it this way. Until now, we get the data pulled down, and we get it being embedded. So the next thing we need to do, we need to push it to the vector database, right? So how can we do that? As I said before, it's better to get it to like a batch inserted, but I think I probably won't show that now. I just get a demo now. So I need to insert. It's called upsert embedding. But before I upsert it, I also needed to initialize collection. And you need to know the embedding dimensions. What's our embedding dimensions actually? What's the embedding dimensions? Oh, dimension is 386, 84. So this vector size should be the one you actually use in your like to check it with your embedding model. This is basically the way how we do it. The initialize it. We don't really need to do it. We just need to give it a collection name, and we should check whether. And that's what I mean, like a code as a documentation. You can just put the things here and say what's the collection name is and what we will return. And then our first step is get the listing connection if exist heap. I need to get the connection, and if the connection name is inside it, it exists. Otherwise, I will create one with my input collection name. So this is the connection name I have. That's the initiate collection work. Then I also need to call it in here, and my initial connection, I probably just call it WebMax. Right. So let's try to see whether we can create that collection properly. Okay, it says the content doesn't have this one. Initiate the connection things. So that's basically because we haven't used the code properly, like their documents properly. We can check the code to get them fixed, but I'm lazy, and the Cloudy is already good enough. We ask Cloudy to solve this problem for me. So it's actually is using the class called a create collection. So we will use it this way, create a collection, and I need to also import the models, right? Yeah, it says I also need to import the models. Import the models, and let's try again to see whether this way we actually. So it haven't get any error. So we can go to say. So we use a for endpoint to find out we actually already created this collection. So which means we have successful there. And we also want it to be resistant. So we need to make sure next time we do it, it shouldn't happen something like this, which means here is haven't go through these collections probably, which means this check part is wrong. Let's check why this is wrong. I think it's because the ways we do the comparison is wrong. So it should be done this way. Let's try it again. Okay. Oh, it's a class. It's not dictionary, so we should access it via the class way. It's still not working. It's a turbo. What does that mean? Then if it's a turbo, we should access it this way. So always like that's kind of the data structure problem. You always check. That's still not working. Let's check. Existing connections and extract the name out. What's the name being extracted? It's called collections. No, that's wrong. That's bad. For collection, in collection, login collection. Let's try to see why it's not working. So it's actually is inside it. So it should be this, and then it should work. Let's see it again. This is the login. What's logged structure? Oh, I know why. And should be the name. If list doesn't have name. It's a pretty nested data structure, so that's why it's not working. Okay, we get it. We get it. Final. It should be something like this because the whole collection itself is inside of this kind of loop things. You need to check the structure of it probably. So in this way, we get it to resistant. So next time when it's already exists, you don't really need to recreate it again. And then the next step is we need to do the insert. Then the insert is you need to insert it this way and the vectors. So let's try. I don't think it will work. And the payload we also want to put in is spatial data, which is in here. And I'm not sure whether it's correct or not. So to get a quick demonstration, I just ask it, is the insert vector part correct or not? If not, fix it for me. Okay, it's actually wrong. So I need to fix this specific one to do the upsert. And does it have other instructions? It's asking me to do the batch way, which is a thing I mentioned before. So you can see actually they already have the best practice built in. But let's try. I don't use the best practice for now. I just do the insert. Okay, to have the error. Let's try to fix the error specifically. Just insert one of the data in. I think it's because this one. This is actually a list should be to list. And let's try. Okay. It's you need to construct this operation point and then do the point, but I'm not sure whether it's correct or not. But let's try and let's just copy it and put it there. I know why this is wrong. I just want to see whether AI can fix it for me. It's already a list. That's because I have done this one here. Let's try it again. It's been successfully uploaded. It's actually solved it for me. That's great. Let's try to check in these endpoints. So we have this one. Okay, you can see the data actually being inserted. So you actually have this vector being uploaded to here. Even with some spatial data, that's kind of very great. And you can find the similar, but we only have one data, so you don't have other similar things here. So under this stage, we have our embedded part also working, a simple version. So we can do the search, embedding search on the cloud now. So for now, we just created four of the vectors again. So you can see I get them all running. So until now, I think the task for the AI module side is done. To get the code to be cleaned, best practice is always check your commit process, like what's there, like what's the code should be committed. And also you should get your code being consistent with others, but we needed to use some tools to help you to do that. Normally what we do is we have a dev.txt. Inside it, we install the black it, this kind of tools we want. That shouldn't be installed when running it in the production, but it will help you to do the iSort black it. Black it probably will take a long time because I think it will go through some of the, it's actually done already. So you can see it will get your code, the importing process, like a sequence in a good procedure. So we have done the AI code and work. So we were committed. So the commit message should be, I have made the progress with the spatial SPATIL data loading and also the vector embedding and uploading. That's what we achieve here, and we should push it to the cloud. And if you use a command line, you need to use this message, like push this one if it's a new branch. But if it's the PyCharm built-in function, it will directly being put to the cloud. And then you can go to the create a pull request actually from here. That's very straightforward. And also you can check that actually from the cloud. So our code should be AI for W here. Oh, not this one. This should be a package actually. So it should be machine learning. This one here, you can see it's just been uploaded. And also I created a PR from the and from our client. But anyway, we get that being merged. So you can check the code here later if you want to implement these two functionalities. Then we still have some time. Let's try to at least to implement a search endpoint. So as we mentioned before, to implement the functionalities in this page, all of the stage one things we already done. The things left is a stage two, which is a data consuming things. To get these endpoints to be working, we need to have endpoints to take the chat as an input and do the embedding, then do the vector search. That's what we need to do. So we just need a new API. That's the beauty part of the RESTful. So just now we have not this repo, this repo. We have this viewer. And you can see it's a standard viewers we have used, but for now we need to have a new viewer. We can call it, and I think we need a decorator. Oh, yes. And then the decorator is basically, I think I mentioned this before. So the decorator is something you just use this add with. It will become like a function on top of the function. So I will say this is a chat. Yeah, chat. Not a response yet, but we have this chat. And inside the chat, because we have a request, we need to have the data as, for example, the question. So you will have a query or question. Let's say, let's define the front end needed to have the question object. If there is no this one, well, not good. I'm not sure why this is too funny. And no, not a response is good. Then if there is a question, we need to do the embedding. The same thing as before, we use a faster embed, which is seeing where's my code. So we need to go back to steer our front end code. Is here. We need to use this faster embed. We had to do that because this thing must happen on the API side. Ideally, this shouldn't be there, but we don't really have a good cloud serverless architecture, so we had to do that. Where is the Django? This one? And bash, I need to pipe installer faster embed. And then after it's being installed, I should be able to use this embedded. And I need to put it in the requirements. Faster embed. Is this called fast embed? Faster embed. Yeah. Okay, it's being installed. Then in the viewer, the next thing we need to do here is embed the question with embed. Then we have an embedding model, and question embedding should be not the text. We have the front end code, our code here to do the embedding, right? So where is the embed? So it's just this time, this line of code, embed. And other than the text, we want to embed a question. And then we wanted to, and it should be to a list, as a list. And then we wanted to do the search on the cogent with this question vector. I think I nearly run out of the power, so I just steer the code from my previous one and trying to get it working first. So it should be in my chat. And this is how you do the embedding. Embed. It actually can embed the text, so we can embed the text also. Let's try to use the same function. It's here. So embed the text and the question. And then next thing is it's needed to do the search. Where is my code and the search? That's the function I write here. So I try to copy it and expand it a bit. UTIX. So because it's needed to do a search, doesn't need to be that long actually. It's just to be to this long. And search means I need to have the conjoint installed also in the API side, which is this one. And within it, we install this too. So we have this one, we need to install it. And we want to search the metadata. If it is a query embedding, it should go to the setting, get the URL and API keys. But under my scenario for now, I just get it first hard coded as UI host or UI. No, what's the client setup here? Something like this, URL and a port. So I need to put a URL equals HTTP localhost. And my port is actually 664. Then I have this client being set up. And then I need to do the search, but the search is a bit complex. I just need to have a collection name. The collection name is actually WebEx under my scenario. So I just need to, in theory, I just need to get this imported to my view. So from WebEx.utilizer import conjoint search. It's partially initialize the module URL. That's weird. Let's go into the that's wrong. Here is wrong. So it's working. And then on search, and my collection name, we define it as WebEx. And then we search for the question, so which is this one. And then we can trying to, I'm not sure what's inside it. So I just get it to a string. And trying to respond it back to the front end as answer this way. So in theory, we should be able to have a new endpoints up. So how can you check that? You can check it here. You refresh it. Just now what we are doing is customize, have a new endpoint. So you can see here, the chat is there. And we can try it out here. And in our scenario is we wanted to have this one in our code. So we have a question and we say where is first. And then we call it. Says authentication is not provided because I don't have the GWT token here. You can see I won't be able to send it. Then I probably, for now, I import permission anything. Any. And then permission class. I probably just get it being examine the permission thing. So want to allow any. It's like you can actually control which specific endpoint you can allow the permission. So okay, this is how you do it. Just forget that. So permission any, add this line, and then we go there to do the test again. I'm good. No, I have the question. Key. Why still say I'm good? Let's print out what's wrong. No, it's having a code. Then let's try to remove this line of code and print the question. I'm not 100% sure what's wrong here, but in theory, this code should be working. Okay, it's actually working. So you can see, I think it's hit another arrow. What's the code? It doesn't have the embedded text one. So actually, I'm right here. So it's embedding. Hash the question and to let's try embedding equals list. Let's try embedding 0 to list. What's the arrow this time? Oh, it's also asked the. I have a project name to be asked. So you will always hit a lot of these kind of arrows during the progress, but let's see what's the arrow this time. Content have no. Okay, it's not search vector, it's search metadata. So let's try again. And doing the debugging is actually the daily life for us. We are the programmer. What's it this time? I think this time is actually working. It's just because the return the. I know. It's because of this. Let's try again. It's because like inserted inside that later work, it's different as outside one. So you can see actually the search is working now, but the problem is we don't have too much things in the embedding spaces. It haven't returned much result. Let's try to see the search metadata. What is actually being searched there? Top K, what's the top K I said? Is 5? No, I don't need all of this threshold. I just needed the embedding to do the searching. Oh, I think my computer died nearly. But I think this until now is actually working, should work. That's the endpoint you should call to do the chat later. And we don't really have time to get the front end demoed. So we probably will conclude it here. And I will put the front end demo recorded in our video up. But as you can see, until now, we actually have all of the components we need there ready in the backend. The next thing we need to do is building this front end, probably with Cloudy, and generate that map interface and send the query to the backend to these specific endpoints we just created and return the data in the front end to do the verification. In this way, you have an end-to-end pipeline to get it working. So I think I will conclude it here for today, and thank you everyone for this kind of 3 weeks journey. And later, when you guys trying to implement the work, the project by yourself and hit any errors, just feel free to send a message and ask us. And also about this certificate, as I said before, like when you progress well with your project, show us the progress. We will issue this like a certificate to you guys. So can be kind of it's not something official, but it will give you some credentials or like a progress check, say you are actually doing something. So okay, thank you everyone. See you guys later. Any question online? Okay, no, then I will stop recording. My computer definitely will die very